Thank you very much, Jackie. Can everyone hear me? Yes? Great, thank you. So as my colleague Jackie said, this particular panel is very interesting. It's going to focus on critical minerals, powering artificial intelligence, aerospace, and clean energy. Very big buzzwords, if you'll agree with me. On this panel, we'll explore how these items I mentioned, how Africa positions itself, and Rwanda as well. We are often referred to, unfortunately, as an ore bucket. We'll delve into that phrase later on. But now is the time to have conversations and ask ourselves, how does the continent, which is wealthy in these natural minerals, how can it contribute to these particular elements of smart technology? So help me in welcoming my panelists. I hope they're in the room. Some I know, some are new faces, so I hope they're here. I'll start with welcoming on stage Samuel Wagstaff, aluminum process and product consultant at Oculatus Consulting from the USA. Mr. Wagstaff, warm welcome to you on the stage. Okay, maybe he's not yet back in the room, but I'm sure my colleagues will get him. We have Mr. Yves Mujambere, Chief Innovation Officer at QT Global Software Limited. A warm welcome to you, Yves, on the stage. Thank you, Yves. Yes. Professor Wilfred Diffran, President of Ames Research and Innovation Center. A warm welcome to Professor Wilfred from Ames. And Dr. Anatoly Agolyansky, Chief Scientist from PrisGuru Inc., based in the United States. Dr. Anatoly? Okay, I'm hoping my colleagues will find a way to please get the speakers. They're most likely still in the exhibition area. So that said, we'll begin with our speakers here. Professor Wilfred Diffran, thank you for joining us, and Yves from QT Global. Like I said, the conversation we are having here is on powering AI, aerospace, and clean energy. For some people, this might be the first time hearing how minerals are actually complementing or contributing to tech. Usually, it's something that's not really at the fore, but this is something we're discussing not only in Rwanda, but globally as well. And my first question to you, Yves, is, critical minerals are the fuel of the digital economy. As someone from QT Global, if you could just share with us your general view of the digital economy vis-a-vis the mining sector, and how Rwanda can contribute to the innovation ecosystem and offer, solutions for smarter and greener futures through mining. Thank you.
Thank you, Diana. I don't know if I can be heard.
Let's put it next to you. Yes.
Yes, thank you. In terms of minerals and the tech, minerals power a lot of the infrastructure used for the tech products. So minerals are used to produce like capacitors that are involved in creating batteries, and the batteries power the EV, the electric vehicles. We're talking about the green revolution. In terms of AI, minerals are used to produce the semiconductor and the GPUs that are now used to, that are available in the data centers and are used to run the AI workloads. So in terms of the evolution of the digitization in Rwanda, which is where QT is mostly involved, we've gone from, there was work done on having the infrastructure needed this is where connectivity and things like fiber and broadband was availed by the government and other sectors. So then the next phase was to have the digital services, so digitizing the services, whether they are public or private. And QT, again, we're involved in digitizing things like the medical records. So we're in hospital management, we've digitized the case management in the justice sector. We're digitizing the civil registry and other civil events. So whether you go to the hospital and your kid is born, so you don't have to go register the kid at the district level, it's done on the hospital with our systems. We also power collaboration among secure collaboration and instant collaboration among enterprises and government. So, and then we see that the next phase is going to be now integrating AI in these solutions to, again, increase productivity. And so how Africa can contribute to that is, as you mentioned at the beginning, we cannot be seen as the ore bucket. So we have to transform these ores and produce not only the elements, but products, whether they're finished or semi-finished. So for example, with tantalum, it's used again to make capacitors. Why can't we invest in manufacturing these capacitors? We're not going to, for example, compete with the biggest in the world, but we can be their suppliers, right? So we can provide the capacitors to these companies that are producing the semiconductors. So we have rare earth here in Rwanda. These rare earths are used to produce magnets, and these magnets are used in the electric vehicles, in the motors and other types of things. So why can't we leverage that and make magnets here and then supply them to the Teslas and BYDs of the world? So I think that's how we can be involved, whether it's in the green revolution by powering by powering or being suppliers to these producers, but we can also be involved in the AI by leveraging our mineral wealth, by transforming it into products that then we can supply to the manufacturers of this world.
Thank you, Yves. I'll definitely come back to you on the question of, why can't we be countries that actually produce these refined elements of mining products that feed into, smart technology. I'd like to ask the audience, can you hear us clearly? Could you hear Yves talking clearly? Yes? Okay, I guess there's a bit of feedback here. Jackie, if you could please help me kindly tell the people at the back to keep it quiet. I believe that's the Ingansongari. My next question is for you, Professor Dr. Wilfred Ndifon, on behalf of AIMS. So AIMS Rwanda, as many of you know, is renowned for its cutting-edge research in mathematical sciences, data science, and quantum computing, with significant applications in health and climate modeling. My question to you is, how can academic and research institutions such as AIMS support expertise in data analytics and mathematical modeling to directly support smart mining? It's a mouthful of a question, I know, so please let me know if it's clear.
Thank you very much. So maybe I should start by telling you a bit about AIMS. AIMS is the African Institute for Mathematical Sciences. We were founded by a South African theoretical physicist called Neil Turok in 2003. And the motivation is recognition that the key technologies that drive economic advancement the fastest are all based on mathematics. So we're currently living in what's called a digital revolution. The foundations of this revolution are mathematical. Our future would be both digital and analog. Increasingly, we're going to have quantum computers help us with information processing. But already we see attempts to make AI more efficient by resorting to analog computing frameworks. So that also is mathematical. So we have current and future technologies that are driving rapid economic growth, which all have a foundation in mathematics. Now, as Africans, we can choose whether we're going to wait and hope that someone will develop the technologies that we need, or we may decide to develop the technologies ourselves. We can use what exists, but make sure we are developing technologies that address our challenges. And if you choose the second route, then you need to build capacity in the foundations of modern technology, hence AIMS. Advanced training in the mathematical sciences at the master's level. And we also conduct research in the mathematical sciences. And recently, we've moved on to develop capacity in innovation. Now, AIMS is Pan-African. We have operations in 5 African countries, and Rwanda is exceptional in that it hosts 2 of our centers. There is the AIMS Rwanda Center, which is providing postgraduate training in the mathematical sciences. Then the Research and Innovation Center, which I lead, which is engaged in research and also ensuring that the research is transformed into societal value. At the Research and Innovation Center, we have 3 main focus areas. We're talking about things like advanced statistics, machine learning, artificial intelligence. These are all really key areas in which Africa needs to lead. Quantum, well, as I mentioned earlier, we have a quantum, an analog future, which will be partly powered by quantum computers. So it's important that as Africans, we develop expertise in this technology and we shape its future direction. And then modeling. Modeling sits underneath all of this because you can do data science without doing modeling. You can study quantum or build quantum computers without doing modeling. And by the way, for those who aren't familiar with this, AI itself is a mathematical model, right? So this modeling is really a foundation on which the other 2 sit. Now, these 3 areas are quite relevant to the objective of developing smart mining operations. I will just focus on one area, which is exploration. Now, it is known that the success rate from explorations based on traditional approaches is not very high. And increasingly, people are now thinking of new ways of doing exploration, whether it's about taking a second look at the existing empirical facts on which the maps of mineral locations of mineral deposits are based, and reanalyzing those data, those facts, using mathematical models and machine learning models, or developing completely new approaches. And one of these is called quantum sensing. So quantum computers are still in the future, maybe 10 years away, but quantum sensing is already being used in a number of fields. And it's particularly useful because you can use it to detect things like changes in magnetic fields or changes in gravity, depending on the density of rock formations in a particular area. You can have different levels of gravity, and you can have these sensors measuring this. So that gives you data. And if you combine this data with machine learning, you can then learn the patterns, the features that are predictive of the presence of specific minerals in different locations. Not just in addition to what you get from quantum sensors, you could also use satellite data. People are increasingly using that. Hyperspectral images that you may collect using drones. All of this rich data can be analyzed and made sense of using machine learning. And so at AIMS, we are building that capacity And as I mentioned earlier, we like to look at foundations. So AI is an evolving field. It's still immature in many ways, still has many limitations. So you want to be applying it with a clear understanding of what the limitations are and how you can innovate, how you can develop new AI architectures, new algorithms on top of those architectures that address specific challenges. So this is an important research area at AIMS. So quantum sensing plus AI can significantly increase the success rate of explorations. There's a company, I don't want to mention the name, but they claim to have success rates of about 75% by using AI. But any significant improvement, I think, will be very useful, especially given the fact that currently exploration is very expensive. So the people who get mining concessions tend to sell the rights to those concessions, basically for pennies on the dollar, because they don't have the means to do this exploration. If you can use technology to lower the cost, then more of these resources will be exploited by Africans in partnership with our global partners. Thank you.
Thank you very much. Professor, I would like to welcome the two gentlemen who've just come in. Apologies, we had to start without you in the interest of time, but thank you for making it. And allow me to reintroduce, starting with the gentleman on my left, Mr. Samuel Wagstaff, aluminum process and product consultant at Oculators Consulting from the USA. Let's give him a warm welcome, ladies and gentlemen. And on my far left, Dr. Anatoly Agolyansky, who's the chief scientist at PrisGuru Inc. from the USA. Let's give him a warm welcome. Ladies and gentlemen. So my next question is to you, Mr. Wagstaff. And earlier on, before you came, we were talking about Africa being considered an ore bucket. And an ore bucket, of many of you will know, is a continent known for its minerals, but it's just, extractive. And, we want to move from that to leverage ourselves as a continent that, there's refinery, contributes to smart mining, and so on and so forth. So my question to you, Mr. Wagstaff, is, based on your experience, how can countries in Africa shift from being passive upstream, branded actors, branded as ore buckets, to becoming competitive producers of refined and finished products with high value stages, for instance, in terms of battery, electric vehicles, and advanced tech manufacturing?
All right. Thank you. I apologize for being late. In my defense, I was at the exhibit trying to get a better view of what's going on in Rwanda today. So it's a really good and fascinating question, right? Because we have a lot of history to go back on, not just why does Rwanda or Africa overall look the way it does today, but also what's happened in kind of throughout history over the rest of the world. And so how do we move from kind of this kind of low value ore bucket, I like that term, into something else. And the interesting part is when you move from that ore bucket mentality over to final and finished product, the value that you're bringing into the stream multiplies by a factor of 10 or 50. So whatever you think the value is in that ore bucket, you multiply that by an order of magnitude more to bring value into the countries. So that's, I think, the reason behind it, right? Why we ultimately would want to do that, because we're bringing more value back to the countries where the ore originally came from. In terms of what would have to happen, or what the goal would need to be, none of this can be built overnight. And so when you're trying to compete with European, American, or Asian counterparts who are doing lots of the refining of African ores, there's a couple of things that absolutely have to be in place. And the first is a very good, robust logistics and electrical power system. And I think historically those have been places where Africa has maybe a negative connotation, that there just isn't reliable power or isn't reliable logistics. And I mean, I flew in yesterday, and I can tell you it's not, absolutely not true. There was no problems in that delay. I think in terms of moving forward, so we're addressing some of those logistics and electrical grid issues. The next piece in a refining operation is to begin to establish those here on site, and that could be through, and we see lots of great success certainly in China by establishing development hubs where there are certain centers where we don't have dispersed refining operations, but we have special economic zones like you have here in Kigali that are specifically designed for the extraction and processing of metals and materials. And so you could see inside of the special economic zone not just Rwandan tin, but Congolese cobalt, Zambian manganese, or Tanzanian graphite, all being refined and manufactured here inside of the African center. So that would probably be the first thing that you could probably establish within like 1 to 3 or 1 to 5 years. And then kind of concurrently with that, there's a lot of other materials that are required, not just those critical materials that we get a lot of buzz out of, but there's a lot of requirements for aluminum, copper, zinc, et cetera, that are just present in lots of these battery materials as well. And while there's not a huge presence of all of those kinds of smelters here in Africa, that's certainly possible to be added, and I would probably suggest looking at a secondary smelter operation, where not just look at and this is probably the mistake that the rest of the world made, was we focused so much on the primary extractive metallurgy side that we forgot about the recycling aspect of it. And so things like copper and aluminum, you have here already present, they're just already in a refined state. They're inside of your buildings, they're inside of your cars, they're inside of what you've already built infrastructure-wise. And the rest of the world is coming to the realization that all of those trash piles and things are actually sources of mine, or they should be mined much closer to how traditional mining is done. And so a secondary kind of smelting operation space would allow for some of those other materials, copper foils, aluminum foils, that are required for like battery manufacturing as well. And then I would say probably the third thing that's probably the most important is to manage the talent pool effectively and deal with and try to manage the brain drain kind of an issue where you have talented students, talented employees who seek employment elsewhere, and so you see this extraction of intellectual talent that's leaving Africa and moving to other parts of the world. And so creating, as a part of those special economic zones, but education incentives and investing in universities and research centers to bring those people back, or extract talent from and just reverse the brain drain and steal intellectual talent from other parts of the world as well, and bring them in to help to develop those refineries and secondary smelting processes, and do the next generation research on artificial intelligence, quantum computing, batteries, et cetera, so that Rwanda or Africa overall becomes the source of where everyone comes to do research and wants to do that manufacturing in the first place. Because this is where all the talent resides, and it happens to also be exactly where all of the minerals are. And so as long as you can bring together where the minerals are coming from and the talent to be able to put them together, any company in the world will find that as the right place to build. Buildings can go anywhere. It's really about finding those minerals and finding that talent and putting those things together that really draw everything together.
Thank you. I hope some of the leading refineries on the continent, the companies are here with us today, because we're going to have a Q&A later on and discuss some of these things. So I believe the Tantalum biggest refinery is based here on the continent. And these are great insights you're sharing. Talent retention, amongst many other things, which we'll come back to later. Professor Dr. Anatoly, my question is to you as a chief scientist from PrisGuru. It's really to kind of break down, we're talking about mining, we're talking about smart tech, but if you could just be a bit more granular. And my question is to you is, at what scale do critical minerals power the mining sector and including artificial intelligence? So at what scale do critical minerals power the next generation technologies in artificial intelligence, aerospace industries, and the global green transition? If you could just give us a breakdown of that.
Thank you. First of all, thank you very much for inviting me. It's fantastic.
If you could just put your microphone closer to your face. Yes. Thank you.
Now you can hear me? It's better.
Yes, we can hear you.
Yeah, okay. So when we talk about future, which is AI, aerospace, electric cars, and so on, we're imagining software, special algorithms, but actually everything depends on and cannot exist without critical minerals. You heard this sentence today. I will try to tell something that you didn't hear. I want to give some examples from my field. The most part of my life I spent for tantalum and niobium, chemistry, metallurgy, application, scrap recycling, everything. And last 20 years I've been working in semiconductors, and actually all my life in problem solving. So when we think about semiconductors, about microchip, we all know it is built from silicon. Silicon. But we don't know, I believe not everyone knows, that the key material is tantalum. Tantalum separates copper lines from silicon oxide, and without tantalum, no one chip will continue to work. And what's the point is that you can replace copper, you can replace silicon oxide, you cannot replace tantalum. Tantalum is so unique, you can't replace it. Another example, tantalum capacitors. You know, tantalum capacitors is just fantastic electronic devices. Each cell phone that now in your you have contains at least 20 to 30 tantalum capacitors. And no replacement. Only tantalum can be used for this. Of course, niobium, as we hear, niobium has very high critical temperatures. Therefore, it is without niobium, you cannot create quantum computers. Even MRI machine will never work without niobium. I'm not talking about examples that you all know that tantalum niobium containing alloys, so-called superalloys, allows chemical processes and allows airspace applications and so on. I want to tell you about the paradox. For instance, a paradox that companies know exactly all fantastic properties of, for instance, tantalum, and they try not to use tantalum. For instance, in microelectronics, people try to develop technology in order to avoid using tantalum, because tantalum is the most expensive material in microchip, just to let you know. Tantalum capacitors. No one of producers like tantalum capacitors because tantalum powder is terribly expensive. And therefore, people try to develop ceramic capacitors, maybe replace tantalum for niobium oxide. Not very successful. But anyway, people invest money into not to using tantalum and niobium. So Rwanda supplies about, as far as I know, 22% of tantalum. And what's happened? Rwanda supplies tantalum, a refinery produce tantalum powder, sell it at very high price, and companies invest money in order to not to use tantalum, which is terrible. I'm not sure you are very happy to participate in such flow. There is only way, from my point of view, is to reduce price. But even if you give raw material concentrate free of charge to suppliers, to producers, they will never reduce the price. The price will remain the same. They will have just more profit and nothing more than that. As to me, the only way is to start producing, to start refinery and produce and process here in Rwanda. It's easy to say, it's not easy to do. Why? Because very often people think we can copy technology, existing technology, which is completely wrong way. Because today's technologies for tantalum, for niobium, they are very expensive by design. They are very old and very expensive. So if you build something like, I don't know, Stark produces or Cabot, you will never win. You should build something new. In order to build something new, you should innovate. Now, the innovation is not something new. Innovation is a result of solving problems. In our case, is a result of solving engineering problems. Innovation is our ability to convert problem into profit. This is the definition. Therefore, we all should start to learn how to innovate and how to solve problems. Solving problem is a science. And only based on problem solving, scientific problem solving, we can create new or at least somehow renovated technology and achieve low price. By achieving the low price, people stop investing money into developing technology to not to use tantalum. Opposite, they will invest money in the developing new applications, how to use more and more tantalum. You know, in the very beginning, aluminum price was close to gold price. And of course, no one are able to use it. And developed technology allows to use it everywhere. So let's start to learn problem solving and innovation.
Thank you very much. Thank you. Very insightful submissions from this esteemed panel. You're talking about increasing talent retention. You're talking about, refinery as something we can focus on. To Eve, you talked about in Rwanda how, why don't we actually challenge ourselves to being people who leverage these technologies to push forward smart mining. So my question now, but it's first to the audience before I come back to the panel. And, there are key players in the audience I can see in the mining sector, not only in Rwanda, but across the continent, and scientists also from abroad. And my question to you is, after what the panel has said, the submissions from the panel, in terms of aerospace, in terms of AI, in terms of smart technologies, how can Africa as a continent, how can our countries, join in this very important trend? Are there some ideas you have in addition to what the panel says? And very happy to hear from you for at least 10 minutes before we go back to our panel for their closing submissions. From the audience, any questions? Sorry, any responses to my question? Yes, there's a gentleman there. There's a microphone next to you.
Thank you very much. My name is Christian Lack. I'm a geophysicist from Germany.
Just, if you could speak a bit louder, or if the technical team can increase his microphone's volume. Thank you.
I'm a geophysicist from Germany, and I very like the panel discussion about smart technologies and machine learning based on exploration physics. My question is, and that also answers your question, are there cross-validating studies where you have drilling cores to investigate the underground and then apply machine learning without looking at the resulting data of the drilling? I think this is one of the keystones what should be mentioned in that machine learning process of exploration physics.
Did you hear this question?
Yeah.
Yes. Samuel, please.
I think that's a great. I think it's a great comment. So the comment, if I can repeat it back, was around using machine learning in exploration, and we should be focusing more on that. So I'm not fully aware of all of the different techniques and algorithms that are used, but certainly in terms of as with any artificial intelligence, machine learning type approach, the quality of the data that you put into the system really dictates the quality of the data back. But we've seen artificial intelligence and machine learning algorithms work in other aspects of metals and machine learning applications where they're able to take resulting compositions of final materials and then predict, or certainly of scrap materials, where you have this unknown quality of scrap that's incoming, and based off of your final metallurgical assay at the end, give you this prediction of the complete bell curve of all of your different qualities in terms of metallurgical qualities, but also compositions of these different alloys that go into scrap. And so while we know that's working in scrap blending in the secondary processing space, there's no reason that it shouldn't be explored and added into the exploration space. It's just a matter of getting the right quality of data to input into the algorithm. And there's probably nothing that replaces just getting out and actually taking measurements, but certainly minimizing the amount of damage and the amount of data that has to be collected will certainly reduce the cost for lots of those mining explorations.
Thank you.
Thank you. Is there anyone on the panel who also wants to answer his question? Yes, Professor.
It's quite difficult to hear well, even when others speak on the panel.
Sorry? You can't hear? Or you can't hear what they're saying?
Yeah, we can hear it clearly.
Okay. I'll just ask the technical team to improve on the comments from the audience, so our panel can hear. There's a sound issue? Is that what you're saying?
Cool. Yeah.
There's an echo, yes. There's also an echo on stage. That's why earlier on, Eve, I was asking if you could hear us, because I was getting the echo from you when you started talking. So if we could just have that fixed as we close this particular panel, and I'll try my best to be as loud as possible and avoid the echo. But any more questions to the panel from the audience? Or comments? It doesn't have to be a question per se. I thought there would be more conversation. This is a very important conversation looking at critical minerals and smart mining, how they contribute to smart technology, aerospace, engineering, artificial intelligence, machine learning. Any comments from the audience? Yes, if you could please stand up.
Yeah, thank you. I'm Dieudonné Vigirimana. I'm working for EcoBank Rwanda. So I have a question to ask. Yeah, my question is around the rising of AI and its impact on the global demand in minerals demand. What has really the rise of AI has impacted on the global demand in minerals? Thank you.
Did you hear that?
Yes.
Please go ahead.
Yes, I can make just a small comment about this. I'm not in the financial business development side of this. But from the scientific side, we know AI currently is very inefficient. So if you imagine you need just a few megabytes of data to learn and master the English language. AI needs many orders of magnitude more. So when you need more data, it also means you need more computing power. So you need more chips, okay? And so we see data centers growing, the number of data centers growing around the world. And this has resulted in a rise in the demand for chips. And of course, as we've heard earlier, these chips depend on the critical minerals. I just want to note that within the continent, and especially at AIMS, there are efforts to try to develop much more efficient AI architectures. Globally, there are also efforts like this. So by moving from these digital computers, which has this problem that you store data in one place, and then you manipulate the data in another place. So you need memory, and then you have the CPU. So one approach to doing that is to implement AI within analog computers. These also rely on the minerals that we've been talking about. But that's, at AIMS, we're also looking at algorithmic solutions to this. So ensuring that we have AI architectures that can learn as efficiently or nearly as efficiently as humans do. If we do that, then we'll reduce a lot of this, the demand on chips for AI computations.
Thank you. Dr. Natoli, did you have something to say? No. Did you have something to say to his question?
Regarding again, this is what I tried to say. AI and increases usage of chips dramatically, and we should allow it. We should reduce the price of tantalum, and this is what will increase demand in tantalum. I mean, you know, tantalum has a lot of applications. Tantalum is the only material that compatible to our body. And I saw a company, they produce indents from stainless steel and cover it with tantalum. I said, why? Because it's very expensive. They think all over the world is thinking how not to use tantalum. This is terrible. We should change it. We should destroy this and reverse this situation. This is what I wanted to leave you here.
Thank you. Any last questions from the audience before we close? Questions or comments from the audience?
Thank you very much. My name is Victor Dennis, a public health specialist and also industrial pharmacology. To me, I think different we solve that even if in a smart area, in smart area minerals and green future, we may see things is somehow complementarity. If they are producing more tantalum and lithium and all that, whereby it is going to be refined over or processed over here and then go to the some developed countries whereby they are going to give a very good cost. In other way, for us, all the things there is some complementarity whereby the thing you are producing selling for the high cost or the increase for you, then you yourself also you may use that reduced cost for your agriculture, whereby you are going to reduce carbon emission, and also you are going to use that in your agriculture, whereby you are going to use electrical things, electrical tractors, and hydropowers. And within the hydropower, that the cost will reduce, and then economic-wise, your people they are going to have a good health because you reduce the carbon emission in your area, and also they are eating very well, and also the production of agriculture will go higher. Thank you very much. That's what I'm thinking.
Thank you for your comment. I'll now hand over to the panel. I hope you can hear me. Can you hear me? Okay, to the panel to give their final remarks. It's been an interesting conversation, looking at critical minerals and smart mining, and the future of the digital economy. And if you could just give your final remarks on how, as a continent, Africa and African countries can really play a more important role in this ever-growing digital economy. And I'll start with you, Mr. Flagstaff.
So I think, how can Africa play a more prominent role in the digital economy? I think there's
via smart mining.
By smart mining. I think there's probably two aspects, and we've touched on it in a couple components of it today already. And the first is to bring as much of that process, that downstream process back to Africa. So that's bringing the refining, the extraction, alloying, production as much as possible back to the African continent, and that has already begun by the introduction of some of these refineries, but there's still a larger room to grow. And I think the second place is to turn Africa into the innovation center for minerals and mining. If we go and do the same thing that every other country did during their large industrial revolutions, we just heard a comment about greenhouse gas emissions, that will inevitably create more problems than what we're trying to solve by lots of the smart mining operations. So I think the second piece is when we bring things back, is to invest in newer technology that reduces those emissions, that does things in a smart way, so that Africa not only becomes the center for refining, mining, and I'll just say metallurgy overall, but it becomes the most efficient and the most economically sustainable place for that to happen. And I think what we'll find as well is, not only does it become the place to bring that economically advantages the continent of Africa, but benefits the world from an environmental perspective as well.
Thank you. Over to you, Samujambere.
My point would be that I think we ought to invest in more human capital development, because we have the advantage that we have lower wages here compared to Europe and the US. So if we invest in human capital development, this will be, I think, in my opinion, a basis to attract these companies that are involved beyond the refining, because after refining you have to produce this semi-finished or finished products. I think I mentioned capacitors and magnets, which are involved again in the EVs, electric vehicles, and as he said, mobile phones and semiconductors. So my point would be to invest in human capital with the view of attracting these companies. And as Africa in general, we have vast wealth coming in already with the export of these ores. We've seen companies like Norway where they invest in sovereign wealth funds. So why can't we have a fund like that from the mineral proceeds? And that fund can be, for example, used to invest in companies and even attract some of these companies to come and have their operations here, their manufacturing operations. So thank you.
Thank you. Just a quick one, Eve. Would you say in terms of investing in human capital, Rwanda is on the right track based on university students in geology, QT Global software? I don't know. I know you work with a lot of local talent. Is this something that you think is happening on the ground in Rwanda?
Yes. I believe there's been tremendous progress. As you mentioned, there's a lot of investment, whether it's in the mineral sciences, but even on the tech side, where I come from, we are recruiting a lot from the local market. There's good universities, but also beyond Rwanda, we also recruit from around Africa. And I don't speak here only for QT, but we have other companies like Irembo and involved in the tech sector that are recruiting actively on the local scene, but also in other African countries. And additionally, I will have to mention that we have a lot of business business companies that are coming in from Europe and from elsewhere looking for talent. Again, because talent is cheaper here, so they come here and there's a lot of people coming in and putting outfits here that are recruiting local talent, working on tech projects in Germany. I saw a German person, even in the US. So there's a lot of freelancing also happening, not only these companies, but engineers sitting here and working on projects in the Silicon Valley. So the talent, we have it. There's a lot of progress in building this talent, and I believe that with schools like Ames, we have Carnegie Mellon here in the country, and there's more that are going to come, I think, even in other countries, so we can develop this and even go beyond what we've achieved.
Thank you. Yes, just very quickly.
I just want to add to Eve's comment. I mean, I think that's probably the untold thing that we haven't necessarily talked too much about is like the cost of innovation inside of Europe and America is almost becoming unsustainable. It's if I go today and I get a grant, if I worked in a university and I got a grant from the U.S. government, and 60 to 65% of that money is going to go towards administrative costs of just operating the university because of how expensive those operations are. I don't know for a fact, but Rwanda doesn't have these kind of bloated, overly large overhead operations, and so any of those grants, programs that would exist inside of Europe, Asia, North America are going to go farther in Rwanda, not just because of the cost of human capital, but because the cost of innovation is lower. And if you have the talent pool and you invest in the talent pool that's here, that money goes further towards those things.
Correct. Yes, Professor, over to you.
Thank you. I want to touch on the word innovation. It has come up a number of times, and it's really key. And innovation is something that Africans have done for thousands of years. We've been transforming minerals for a very long time. I'll tell you something you probably don't know. In the 19th century, a technology for converting carbon into steel was patented in Europe, but similar and even better versions of that technology existed in Africa hundreds of years earlier. So in the Congo Basin, people had been developing really advanced technologies. And so if we promote innovation, so we just need to build the capacity of young people, introduce them to problems, interesting problems. They're going to produce things that are currently unimaginable. And as has been said, the cost of innovation has already risen to unsustainable levels elsewhere. People will be coming from elsewhere to get technologies from Africa that will be much more affordable. One example is AI, which we've been talking about. So-called large language models cost a lot to develop in the US. But you see the difference in costs when it came to developing DeepSeek. So by being very creative in engineering, in science, you can build really good technology at very low cost. So there is really an opportunity for Africa to lead in smart mining by building the technologies of the future, which others will come to take.
Thank you very much. Over to you.
Yeah.
Mr. Anatoly.
I will try to continue what you said about innovation. People very often say me that we don't need to learn how to solve problems and how to innovate. We innovate anyway. We are doing something new. Our brain is built like this, that it is very easy for us to build something complicated. And it is very complicated to build something simple. Have a look on chips. When I started to work in Intel, we have 3 to 5 interconnection levels. Today, when I left Intel, we had 16 to 18. And I know what's happened the next. It will be 22, 25, because this is our brain is built like this. In order to log in, today you should prove that you are not animal, that you are you, and it's terrible. And it has no functions. So innovation, real innovation, is based on the problem solving. And this fantastic future that we are talking about, I think it's future of people that are educated not only in engineering science, not only in physics, chemistry, mathematics, material science, but also in problem solving. Because, what I learned from my very long life, when people cannot solve problem, they fight. And it could be between two people, it could be between two groups, it could be between companies, it could be between countries. I just want to explain you the value of knowing how to solve problem innovatively. So, thank you.
Thank you. Very, very interesting food for thought there. Please help me give this esteemed panel a big, big round of applause. Thank you. And I hope in the next few days we'll be having a more vibrant discussion with the audience. The audience today was a bit quiet. Let's hope in the afternoon and the few coming days, vibrant discussion across, minerals for a smarter and greener future. My name is Dana Mpisi. It's been an honor to be your moderator, and I'll now call on to Jackie to please take the next steps. Thank you.
Thank you very much. Let's appreciate Diana for the wonderful moderation. And we appreciate all the panelists for their contribution. Dr. Anatoly, Eve, Samuel, and Professor Wilfred, we appreciate you so much. Thank you as you take your seats. I'll be giving you a few minutes break to go enjoy your lunch. That conversation, Diana said it, we expected the audience to be all psyched up and full of questions. What happened? What happened? Was it that that team was very clear, eloquent, the explanation was fantastic, the language was easy to understand, or was the language too heavy? Or you guys were just not in the mood for questions? The language, eh? They're hungry. Are we hungry? Diana says we're hungry. Are we hungry? Okay, now that we're taking lunch, we're going out for lunch. When we come back, I hope we will do better and have questions. And it's day one, so we will let that pass. But for the rest of the days, let's make sure we are fully engaged. Let's ask those questions. It will be bad for you to take part in Rwanda Mining Week. Come sit in this room. There's a burning question, and you go back to your country with it. Let's not allow that to happen. So take notes and have those questions come through during Q&A. Lunch has been served. Please, let's take an hour for that. So I'm hoping to have you back here. It's now 1:24, so 2:25. If you can come in about 2:10, we'll be very happy. And then we can start our next panel discussion. This one was on powering AI, aerospace, and clean energy. In the afternoon, after lunch, we'll be talking about robotics for smart mining. Can we please clap for ourselves for being a wonderful audience? Thank you. Enjoy your lunch. Bon appetit. See you later.